collected by natural waterways, flows downstream. Much of this water is used again and again for agricultural, industrial, and domestic purposes. The wastewater is received by treatment plants, and after meeting pollution control requirements, is discharged back into rivers and streams. This process is repeated hundreds of times as water journeys toward the sea. Collected, stored, and used many different ways, water and wastewater is constantly measured, recorded, and analyzed with flow instrumentation products, engineering tools for water and wastewater management. The need for water and wastewater management and flow measuring products became necessary when human population centralized, crowding into cities. Early 20th century engineers implemented programs to manage growth. Millions of miles of sewer pipes were installed, drinking water and sewage treatment facilities built. Today's engineers are replacing obsolete sewer pipes. Sewage treatment plants are expanding and updating to keep pace with heavy population growth. Population has grown so rapidly in some areas that both drinking water and sewage treatment plants are often shared by multiple townships and municipalities as a practical, cost-effective measure. The expansion of water and wastewater facilities has created a demand for new, versatile flow measuring products for full pipe and open channel applications. Many of these new products were researched and developed by Marsh McBirney, internationally recognized for advances in flow measuring instruments.
But we're a lot better than we were on the last shape. I think we're going in the right direction.
Here's there. Let's see what we've got.
We're still good at 2. Let's take it on up a little bit.
Okay.
It was Marsh McBirney engineers in the late 1970s who designed a revolutionary flow meter with a measuring capability that went beyond the limits and ranges of older technology, like flumes and level-only devices. This new flow meter measured both level and velocity. A probe mounted on a stainless steel expandable band was placed in the flow at the bottom of a pipe. The probe housed 2 sensors, one sensor to measure velocity and another sensor that measured level. As water flows by the probe, both a local velocity measurement and a level measurement are made. The local velocity signal is converted to the mean velocity through empirically established relationships, while the level measurement is converted into area through known geometrical equations. The Marsh McBirney technique utilized the continuity equation that flow Q is equal to the mean velocity V times the area A. Instrumentation implementing this equation is accurate at both low and high flow rates, and even when downstream blockages cause the water level to rise and the velocity to slow down, accurate measurements continue to be made even when water rises to surcharge conditions.
This is the towing carriage that I was telling you about.
Marsh McBirney began to calibrate their sensors utilizing an in-house towing carriage. Towing carriages like this one are the preferred method of calibration at government installations and major universities involved with sensor calibration. And at Marsh McBirney, sensors can be tow calibrated to achieve an accuracy of 1/4%.
You would never need to open it.
Yeah, but okay, now if you do that,
Perhaps a battery compartment.
well, how do you talk to it then?
Epson has just come out with a new notebook computer.
In the mid-1980s, a survey of hundreds of Marsh McBirney customers resulted in major engineering changes in its flow products.
We've got to make the system so simple to use.
Based on this survey and other customer contacts, Marsh McBirney designed new features into its permanent and portable flow products.
Pushes the button that's labeled to do what he wants to do.
So you wouldn't have to have any prior computer experience per se, just simple keystrokes.
If you can deal with a TI calculator, you should be able to deal with this.
The new products incorporated commercially available laptop computers that both simplified flow data collection in the field, as well as provided simple-to-use interactive software for computerized flow analysis.
Did anybody mention water tightness?
To collect flow data during surcharge conditions, the instrument was made watertight.
This O-ring seal then will seal up against this surface in here?
This is what keeps the water out of the unit here, is this ring right here.
What are you doing about reliability?
Reliability was built in by sealing the electronics, thereby protecting sensitive components from hostile environments. Additionally, a fresh-from-the-shelf, long-lasting battery made collection and storing of flow data possible for several weeks at a time.
Okay, I also think that we're confident now to the point where we're saying that we have a unit in mind that the 265 user is interested in purchasing. Before we even talk about beta units or anything like that, we're confident with the data we've gotten from our customers, and our service department is always in close contact with our customers. They have a lot of inputs, to the survey as well. I feel that we've, researched it to the very end, and we're ready to go.
After months of research, product development, and testing, a major new flow measuring product evolved, FlowTote. The FlowTote adapted well in sewer vaults and manholes. In this application, a probe placed in the flow measures level and velocity, sending data to a battery-operated, watertight downhole unit, which collects and stores flow information for several weeks at a time. A laptop computer, easily operated even by non-engineering personnel, collects the stored data. Marsh McBirney engineers chose the electromagnetic technique for the probe's velocity sensor because of its proven ability to operate equally well in both raw sewage and stormwater. The electromagnetic technique also allows for high correlation accuracy between sensed velocity and mean velocity. The probe's level sensor operates even in rapid flow environments. The patented shape of the probe virtually eliminates level errors caused by the pitot effect of rapidly moving water. The probe's upswept shape prevents paper and other debris from hanging up on the probe, so measurements are possible for long periods without fouling. An enhanced unit is also available with multiple input channels to log additional engineering data from analog sensors, such as temperature, conductivity, and pH, as well as keeping track of contact closures from devices such as rain gauges. The unit is also available with a contact closure that allows samplers to be triggered at a rate proportional to flow. The downhole unit is periodically interrogated to extract the stored data or to input new information such as site location, pipe size, and data collection cycles. One processor easily serves many sites in a single field trip. Measurements can be further processed by the portable processor or by more powerful engineering computers using a variety of Marsh McBirney available programs. Marsh McBirney has developed programs that allow the data to be formatted so as to provide professional presentations usable by both engineering and non-engineering personnel. Other FlowTote instruments utilize an insertable flow meter for full pipe applications. Multiple input channels available on these instruments permit simultaneous monitoring of other sensors, such as temperature, pressure, or even other flow meters. FlowTote's capabilities caught the attention of municipalities and private industry, as well as consulting engineers around the world, and one of the many reasons was portability. Transporting the lightweight tote from place to place is easy. One instrument can serve many measuring sites. That's an important advantage where flow engineers are busy with engineering and environmental studies, like the Chesapeake Bay in the eastern United States, home of the famous skipjacks, used for over a century to dredge for oysters. These skipjacks, skimming the bay waters where the legendary Blackbeard once sailed, are experiencing a serious decrease in oyster harvesting. There has been alarm here over the decreasing marine life, and the study of potential pollution sources has intensified. This infrared satellite photograph of the Chesapeake Bay can point out the many problem areas of pollution. However, flow studies continue to be the key water and wastewater management tool to keep bay pollution in check. Commercial fishing is a way of life here, and the catch of the day is directly related to unpolluted bay waters. Threatened is a centuries-old way of life brought here from England in the 1600s by ancestors of these hardy watermen. Engineering studies are also necessary here for expansion of water resources and treatment facilities to deal with increasing population growth. These flow studies require flexible monitoring for a variety of applications and always a variety of pipe sizes. A simple adjustment allows the band to increase or decrease in size, making installation easy. And a few hundred miles north of the Chesapeake Bay in Oaks, Pennsylvania, easy installation is a definite advantage to Bill Rochon, who oversees a regional flow monitoring program. Flow monitoring demands are on the increase here as townships are sharing treatment facilities and depend on a number of flow totes to document billing.
That's why we're metering it. That's why we're metering each hole, each meter pit here. So everybody pay their proper share, and that's the idea of this program here, and that's why we...
You can see for yourself how easy flow tote is to install. Using simple hand tools, the sensing probe is positioned on the expandable band. Specially designed fairing tape binds the cable to the band to prevent the collection of debris on the cable. A proven method for well over a decade, this mounting system allows the probe to sit securely in position at the bottom of a pipe for months without extensive maintenance, even in tough flow environments like sewers. It takes just a few moments to prepare, and once the sensor and band are ready for insertion into the sewer pipe, installation is quick and easy. Before leaving the site, the user inputs instructions to the downhole unit by using the laptop computer. For operating outside in extreme weather conditions, completely watertight processors are also available. These engineers in America's West are getting ready for a snowmobile ride to retrieve flow data from a remote Rocky Mountain location. Representing state and local water and sewer departments, Clyde Greenwood and George Sivers are joined by Roger King, a Marsh McBirney field representative, for a long snowmobile trip to this distant mountain peak, where this flow tote has been collecting and storing important flow data during the past winter months. The downhole unit records the runoff of the melting snow. Snow accounts for up to 98% of the year's moisture here, and the subsequent spring runoff is stored for the use of surrounding municipalities and townships. The runoff is channeled to reservoirs by these ditches. It is this network of ditches that ensures the runoff will find its way to the proper jurisdiction. The snowfall and runoff are carefully measured to provide the flow data necessary for year-round water management. Over 50 years ago, large ditches were dug by hand and mule to manage the melting snow for population centers around these mountains, and still serve their original purpose today. At the flow site, these field engineers must first dig out the flow tote buried beneath several feet of snow. That's the hard part. The flow data is retrieved with one keystroke. The data is later transferred to an in-house computer for flow reports and further data analysis. Back east, a different kind of runoff is of concern. The measurement of flow in man-made and natural channels in urban areas is necessary because of the need to properly manage stormwater runoff. Since much of the ground in urban areas like this surrounding Rock Creek near Washington, D.C. is covered by concrete and other non-porous surfaces, stormwater runoff can quickly fill local streams. The reaction of these waterways to storm events is carefully logged. Portable flow measuring products from Marsh McBirney provide instant velocity readouts for rapid gathering of data. Easy to read, quick response. This portable velocity meter is a direct replacement of mechanical units used by the U.S. Geological Survey and is often used to calibrate stream gauging devices. Flow monitoring needs vary, and some are unique.
Good morning, Marsh McBirney.
Marsh McBirney is committed to matching the proper flow product with each user's specific application needs.
Coming from the main plant, or is it a branch?
It can begin with a telephone call to Marsh McBirney for an initial application discussion with a flow consultant.
So we set it all up, leave it, come back?
Or discussion of flow applications at industry trade shows or conventions. Field representatives from around the world are trained extensively at Marsh McBirney to keep their customers informed about the latest flow technologies. Marsh McBirney products are featured in national and international trade journals through advertising, technical articles, and product bulletins. Marsh McBirney instruments are backed by both in-house and field service technicians, allowing for quick response to most customer needs. Computerized records provide for detailed analysis of customer records. And there is constant involvement of Marsh McBirney engineers, technicians, and support personnel to ensure that Marsh McBirney users have access to the latest in flow measuring technology for use in water and wastewater management. The quality of life on our planet is directly related to the quality of our water. And Marsh McBirney is committed to providing quality flow products for engineering the future.